Very good.
Hi, everybody.
And with this, I would like to start officially last webinar of year 2025 from 3D survey team with topic top 3 topics explained. So on a screen, you can see already how powerful 3D survey is, what kind of technology can you join in the same software. And today we are again going to talk about the different technologies, different options, what everything is possible. So let's start with the team who is going to present this webinar. And today with us is Matthias Zupan, our quality assessment manager. Mattia, feel free to say hello.
Hello, everybody. I'll be, harassing you with the poll just in a minute. Yeah.
Very good. Then Vit, as we already mentioned, our December surprise guest. He will explain you the last topic of today's webinar. You will see short. You will see in short. Vit, feel free to say hello.
Hi, welcome to the webinar. I had to not miss the last webinar of the year, so I also joined with you today.
Okay, very good. And let's have a quick view about today's plan before we go to the survey. I believe month ago or something like that, you get the invitation to a 3D survey about the last topic of the webinar via email, via social media platforms, or anything like that. We get quite a lot of answers from you. And here you can see directly results, and we sort those topics based on your votes. So number 1 is best mapping practices. So looks like there are still a lot of users, a lot of drone mapping companies outside. They would like to know a bit more in detail how to map efficiently, because this is super important to get a nice model, to be efficient in your workflows, so not to wait 3 days for the results. Everything starts on a field. Most of us are also surveyors, and we know exactly what this means to us, okay? And that's why probably this topic is so popular and powerful, and we'll talk about this one right at the beginning of this webinar. Then point number 2, SLAM devices and workflows in 3D survey. Mattia will present you this topic. Again, super popular, probably SLAM. It's one of the most interesting stuff which was happening this year, because of mainly all survey providers of surveying equipment, they push this technology to the customers. It's still pretty fresh new technology. Some of the brands just release new devices. We test them a lot. We have some experience. We get a lot of feedback from users who are already using this technology in 3D survey, and all this we would like to share with you today, and Mattia will do that. And then third, custom surface design, usually for volume calculation. Vit will present this topic. It's super interesting one, because with a lot of trick, a lot of different workflows, a lot of hacks and everything like that, 3D survey can be super powerful also in this step, okay? So you can design your surfaces, you can import the surfaces, you can edit them, manipulate them, you can lower, higher, I don't know what, everything will tell you most of it, okay? Very good. And this is kind of a short introduction, but before we go to the best mapping practices, I would like to give the word to Mattia to start a short survey with you, that we can have a feeling what kind of audience we have. So Mattia, feel free.
Thank you, Marco. Hello, everybody. Hello again. Well, to warm you up, we have a few questions for you. First one, you already know by heart, so let's just launch it and get over it. So, are you already a 3D survey user? I bet you didn't see that one coming. Cast your votes, and yeah, I see you're trained already to do this one. We got 60% of votes in the first few seconds, and the number is still going up. So also, if you just trial, maybe you can also check the yes one. And okay, getting there. If you just joined us, don't hesitate to tune in. The question is simple, so let's close it up now and close. Here are the results. The majority of you is already a 3D survey user, so 84%, and 16% not yet. So we have something for both answers, so you should get some useful feedback. So the next one, a bit more tied to today's webinar, was your topic on the list. So we chose a few topics that we found are like top topics for 3D survey, top features, most requested and most talked about, but perhaps we missed one. So maybe there wasn't on the list, and if it wasn't, please give us some hint in the comments or question what it was, and perhaps we can look into that next time.
Okay, poll is active probably, huh?
Yeah, the votes are coming in. A bit slower this time. So
Okay, let's think about it. No rush.
just a few more seconds to think about. Okay, let's move on to not waste too much time. So the results are clear. Most of you found your topic on the list, and those of you who did not, please give us a comment what it was. Okay, we have two more for you. So this next one, think about it. How well do you understand the topic you chose? So did you choose it because you know it so well and you just like to see content on that, or is a topic that it's interesting to you but you don't know it well enough? So you go from 1 to 5. If you understand it very well, choose 1. That means very well. And if you don't understand it at all, choose number 5. So this way, we also get some feedback on how to meter our professionality today. Or if you all answer poorly, we'll just use the simple words. But I see there's no fear of that. You are somewhat knowledgeable about these topics. Okay, a few more seconds.
Okay.
This one's a bit more interesting. And closing. Here are the results. A lot of you know your topics very well, 22%, and 27% know the topics good. Then somewhat is the leading option, so 39%. And some of you, we don't blame you, know the topics poorly, but that's why the webinars are for. You can get to know the topics better.
Okay,
All right.
very good.
Just last one. It's a bit of a new question, so get ready. Here it is. Which channel do you prefer for staying in contact with 3D Survey? So it's a question about social media. Where do you like to follow us? Where the content is best? How do you like it? Yeah.
Yeah, and maybe which channel is the best for you to get more info about 3D surveys. Sometimes it's hard to reach you on the right time, with all this quality material. We are producing a lot of it, and it's great to know what best fit for you also.
Okay, sorry if we limited this one to just one answer. I guess some of you would all answer all of them if it was
Yeah, or
possible.
maybe no one also, but probably if there was just space for 5 answers, huh?
Yeah, it's just for 5. Yeah.
Uh,
Don't worry, we won't activate TikTok account or something like that. Uh, anyways, let's see the results. Yes, the majority of you
mhm.
are old school, using email. That's very nice.
Old school and efficient, huh?
Yes. Uh, and the other ones are sort of between 10 and 15. YouTube is quite high on 22%. We try to produce quality material, tutorials, and webinars and guidelines on the YouTube.
Uh,
So
okay. Mattia,
if you
this is
don't,
nice
yeah,
motivation for you. This is super nice motivation for you.
yeah, we just released new tutorial for absolute beginners. So those 15% of you, go check that out. So no
Okay,
excuses for not knowing how to use the software. Okay, these were all the questions. Thank you for contributing your answers, and thank you for engaging. Now, back to Marco.
very good. Thank you, Mattia. Very precious back information from your side to us. And yes, now let's continue with the real topic we would like to share with you. Number one, best mapping practices. I prepared some project. I prepared one PDF where we can discuss about this one, and I will try to mention all most important things. Vit or Mattia, please correct me or add something from your side also if I forgot something, because it's a bright topic and everyone also makes maybe a bit different, because all this information comes just purely from experience and knowledge. And first one I would like to start with, so let me show you one PDF document which I will also share with you via the link on the webinar platform at the end of the webinar. So this is one, let's say 20 pager where we prepared actually drone mapping guides. As an introduction, there is described what should you know before you start doing drone mapping and everything like that, how the weather is connected, strong sun, shadows, and everything like that. But I would skip this first part and I would directly start with the best mapping scenarios for specific projects. Okay. And number one, I would like to emphasize is the best mapping techniques for the best 3D model. So you have a single building, single house, warehouse, or I don't know, anything, church, anything what you would like to map in the best possible way, what you can do. Okay. And I also have the same project in 3D survey here open. And here, this is as a result, you can see a textured 3D models, super detailed with everything. And the blue pyramids are actually camera positions, okay, where the images were triggered. And as the same as in a document described, for a single building, I would say you would need approximately 500 images or something like that. This should be more than enough to capture everything detailedly. In my case, I shoot a bit bigger numbers, so we can see here 680 images, but it was really tricky example because there was a lot of trees close to the building, a lot of hidden spots and everything like that. But in general, our suggestion is first, do a simple grid mission on a 40-meter height, so AGL 40 meter or something like that. Cameras pointing perpendicular down. So I believe in a DJI drone, this is minus 90 degrees camera gimbal, and just collect the wider area around your area of interest. Then we suggest you to do a circle flight mission or fly it manually. In this example, I actually fly manually around the building in a circle. And if you do the first single grid mission on a 40 meters height, the first circle should be on 30 meters or something like that. So what's here important, you need to keep some scale variations, and don't go from 40 meters to 5 meters because the software is not going to handle this one. Go first 40 meters, then first circle on 30 meters, second circle on 20 meters, and next circle on 50 meters or something like that. And circles are pretty strong that connects all the cameras nicely together and generate nice 3D model. Then when you're pretty low, and you're not able to collect any more circular images, then just focus on a specific spots where you would like to have a nice 3D model, a detailed 3D model. Again, you can try to write in a circle way, or you're just going up and down and mapping your area of object from different perspectives. What is here super important, most of the today's made drone, they also have options to turn a camera a bit up. So you are not mapping, you're not taking picture just from the horizontal perspective, you're able to turn your camera even a bit up. And this covers then also nicely this kind of details, okay? That you don't have any holes then inside, that you have a nice 3D mesh, nice texture also under here. Also here under the windows, as we can see, if I wouldn't have this kind of images which would pointing up, I'm not able to get this kind of detail, okay? Then trees are always tricky to have them. To have a nice model means you will also need to have a nice 3D model of a tree. So let's focus on this one. This looks really nice. And what's great to know with trees here is it's great to map them for a bit further distance. So don't go 5 meters to the trees, because if there is a windy day, they were moving a bit and the leaves are not going to be on the exact position. And if you have too much details, the reconstruction, it's not successful. So those images for the further distances, like those nadir ones and those 3 circles or even 4, they really have really much about the trees. I could do a better job from this highest one. As you can see, it's not perfect, but this is because I don't have a lot of enough images from the high perspective down. Then there are some critical spots. If you like to get those AC really nicely, you need to have here images from 2 or 3 meters away from the building facade. That's why I also decide in this way to do the manual flight around this building. I'm flying with the drones for more than 10 years. This is not a problem for me. And if you are in the same scale, the manual flight is always, if you ask me, the safest one, because you have the good control over the drone. Even if you fly half a meter to the tree or something like that, you can always stop. You have the control. Another option I will mention later on, fully automatic mode, is also a good one, but in this case, I probably couldn't cover these spots so nicely. Okay, so I prefer to fly manually in this kind of examples and really nicely cover all the spots I would like to have on 3D model. Okay, I believe this one was even not calculated with the latest version of 4.0 with the super improved 3D mesh, so it could look out even nicely. Okay, so if we get back and repeat everything what's important, do a single grid mission, do circles around the building. Okay, what's important, when you change the flying height of the circles around the building, also change the camera angle, gimbal. Okay, always point your object of interest in the area of interest in the center. Okay, and when you trigger images in a circle, every image like every 2 or 3 seconds if you fly constantly, so you will probably get 50 or 60 images per circle. Okay. From the top down, it looks like that. Focus on details. Don't forget to do that. Another critical spot here. Yes, for where is the entrance of the building. If you would like to have a nice one, let's see. You see all those blue pyramids, how many of them we have it here. If you like to have a nice one, go closer, don't worry, trigger them. Even later on, if you like and you're afraid to fly close to it, you can hold the drone after you turn it off in your hands and trigger it like that way. We also did this in past, okay? Important is that you get images. And then here, as I already mentioned, turn the camera up. You have, if you have option, that you will be able to get these nice sharp edges also. Okay. Then vegetation, don't forget it. They also made a super impressive look of your 3D model. So once again, this is all described also in this document. And before I go to second mapping scenarios, I would like to say also another option, this was manual flight mission. Another option is fully automatic flight mission. More of the drone providers offer this option. I know DJI has very powerful options. So if you have an open area with the building, not too much vegetation close to the building, you can map fully automatically, super nicely, the complete building and surroundings around it. It's super powerful. Two things what you need to know. I think they are overrating a bit with number of images. So with the fully automatic flight, you get super simple 1,500 images per single building. Which is what it means. The processing time will probably go really up, but nevertheless, at the end, you get a nice 3D model. And the second thing you need to know, if there are some small defects like trees without leaves, or I don't know, small cables from the power line cables, the small ones, the drone, even if it has a super powerful automatic detection warning system and everything like that, it could happen that you hit something. Okay, so be careful. Track your drone where it is, visually see what's happening in air, and if it's too close to everything, continue manually. Okay. Otherwise, use this also option to map fully automatically if you like. Okay, and this is our first scenarios. Then the second scenarios is actually drone mapping tips for large rural area. We will check this one through the document. So in case you need a simple orthophoto, and you have a large rural area, some customers are mapping areas like 200 meters per 10 kilometers or 3 per 2 kilometers or something like that. And if you need just a simple orthophoto, in some case, the single grid mission, it's powerful enough and delivers your results in a faster way. So no need to wait for the long processing times. There are also some of other benefits of traditional orthophoto if you need to calculate it out. So this is great to know. If you need actually a 3D model of, okay, no, we are still in rural areas, so this is the best option if you have almost purely terrain with no buildings or anything like that. So something like that. If the terrain is important and orthophoto, a single grid mission is good enough. What's great to have it here is at least few of the side images that the bundle adjustment, the focal length calculation is recalculated better in a better way. I know DJI, after finish a single mission, it flies to the center of your area. and turns the camera in 45 degrees angle or something like that, and just map additional 20 images or something like that. Depends how big is your area for mapping. This definitely helps you to get the better focal length calculation, and this means that you will also get more accurate results about the heights on the terrain without ground control points. Okay, if you don't have these images, the focal length could be maybe off for 10, 20 pixels or something like that. So if you have these options for your drone, turn it on, that at the end the drone trigger few additional images, otherwise trigger by yourself few side images, could be on the same height. Okay, and in this way you are the most time efficient. So you can cover, let's say, 500 per 500 images in a single grid mission on an 80-meter height, or even higher if you go to 100-meter height with a 200 or 300 images. Okay. If you choose oblique selection or something like that, then you can quickly have 1000 plus images. So depends what you would like to have it. Okay. Then the next scenarios. Okay. Okay, before we go to the dense forest, the next scenarios, if you have a large urban area, so like city centers, villages, or everything like that, the double grid mission or oblique missions, so where the camera is pointing left and right and down and front and back and all this, what's happening, it's of course super efficient. Okay, so you have these options for the urban areas. So let's say where you have a lot of houses, not just a single building, you would like to map entire city or something like that. This is very effective way. So it's fully automatically. We advise what's here important to know. When you have side images, the resolution, it's of course not the same if the camera is pointing down. So if you do a single grid mission or 80-meter, you will probably have the pixel resolution of 2 centimeters. And this is probably in most cases fully enough for most of the projects. As soon you go for oblique missions, the camera is turning in front, back, left, right, and so on. So this is kind of a diagonal distance. So if you set the flying height, so AGL, to 80 meters, this distance will quickly be 100 or 120 meters, depends on the terrain. So our suggestion is, in this case, if you are able, go a bit lower, fly a bit lower. So instead of 80 meters, go to 60 meters. If you have smaller area, even on 40 meters, okay? And with this, you could get a really nice model from the entire city. Okay, cool. So this is already third scenarios. Let's focus on my first scenarios. This is also pretty often based on feedback we get from you users. So we have a forest area densely covered with vegetation, or pretty the same one. It's also if you have a water areas, a lot of or rivers or small lakes and everything like that. In this case, what's the most important? Let's go with the forest first. Fly at least on 100 meters AGL. Okay, because when you type these settings in the drone mapping software, the overlap, it's calculated based on the ground level. Okay, and if you have dense trees, and trees are, let's say, 30 meters higher or something, or even more, you need to have also overlap on these tree tops if you like to get them, and if you like to get that image are successfully bundle adjustment together. So it really helps if you fly on 100 meters, or even better, go to 150 meters. In these cases, you usually don't need such a high resolution of images, so even with 3 or 4 centimeters, you would be probably satisfied enough. The technique that you're flying high enough helps you also if the trees are moving during the data acquisition, so that we can still connect those features we are calculating out from the with the help of bundle adjustment later in the office. Okay, and our suggestions increase the front overlap and side overlap, because if you have high trees, you need to have also some tie points on the top of the trees and everything like that, because in some areas you will probably not see the terrain because of the trees. And our suggestion is increase the front overlap to 90%, because drones can quickly trigger cameras, and it's actually the same way for you. When you do the mapping, you will not be able to cover smaller areas because of this, and you're more on the safe side with the processing. And increase the side overlap to 80%. Okay, so standard mapping is 70%. If you are above the forest, increase to 90 front overlap, side overlap to 80%. Okay, and camera angle pointing 90 degrees down fully, and that's it. That's one of the most efficient way then also to get these results. So you can see here one example I did with the mapping. So here was super dense, here was super dense. I couldn't even get any terrain points. And definitely if I would fly low, I wouldn't get this kind of tree details out. And then this affects in a 3D survey as a gray out image. And then customers are calling us and asking why are some of the images grayed out? And this means those not all images were able to calculate it in a bundle adjustment. So we have also here some of them I would like to show you. As you can see, this one image, and in this example 681 images were in the processing, 677 were able to successfully match, because we are not over the high vegetation forest or something like that. And then the grayed out image was this one, probably because of the sun, because of perspective, or anything like that. Okay, cool. Now you probably know a bit more about this one. Then if I also take the parallels to the river sides, so where you have water and small lakes and everything like that, it's pretty similar, because reflection on water is of course the worst thing for photogrammetry. It's never the same from any perspective you see it, it looks differently. And that's why it again helps if you fly higher, that you have also wider area of the lake, not just the lake, but you also have a bit of terrain around it. This really helps you. If you have a river, if you need to map a river, don't have just the center images from the river purely water. It's not going to help you anything. The best way, you go so high that you get also the river bank from the left side and from the right side, or at least 50% of the river from the left side, and then the other side is water. And in this way, you will be able to achieve then a nice orthophoto, not sure what kind of model, of 3D model, for this kind of terrains. Okay, very good. Mattia, any additional things until now?
No,
or I can
think
continue.
you covered nicely. You can continue.
Okay, thank you very much. Thank you very much. Very good. Next interesting one, drone mapping for stockpile volume calculations and monitoring. So in a stockpile, in the volumes, we have usually two scenarios. One are stockpiles, which are usually nicely open on a flat surface with some material on it. Again, with this one go pretty the same approach than with the unurban areas. So a single grid mission, it's in most cases good enough. Again, don't forget to leave the drone to trigger additional images when it's traveled to the center of the mapping area. This will improve the focal length calculation. Automatically, the height calculation is calculated better. And of course, if you are doing some comparison between first measurement and 1 month later second measurements, have some identical points. Use ground control points if you have option. If you don't have ground control points, at least search for the same detail which is on a first measurements and on a second measurements, and combine them in 3D survey. You can import multiple point clouds, multiple surfaces in 3D survey, easily combine them together, see if there is a difference in 10 centimeters, edit this so you're able to manipulate points, meshes to set it to the right height, and then you're confident to calculate out volumes. So if you have a kind of these scenarios, a super simple one, don't need to complicate it with oblique methods, with a double grid and everything like that, because it's visible from the nadir images with a minus 90 degrees gimbal. It's good enough, and you will be twice faster on a field and 5 times faster in an office. If you have time, feel free to trigger all these additional images. It will just help, of course, but depends what you would like to achieve. Okay, then the second scenario with the stockpile is with the bigger mines. I don't have this example prepared yet here. It's an ongoing document where we are adding those specific scenarios, but I would try to describe you. So some of the stockpiles are attached to the hill or something like that. And in this case, it means sometimes those stockpiles could be even higher than 200 meters or something like that. And in some cases, you are not confident to fly so high because you would need to stand on the lowest point of the stockpiles, do the mapping, and then go up at least 80 or 100 meters above this stockpile, and it means you would fly on 300 meters AGL. And if you are not confident with this, there is another option to do it. Not sure how good it covers the terrain following mode, and oblique option could be this a nice solution for this kind of scenarios. Or the second one, you do the single grid or double grid mapping for the lower terrain on a flat surface, and then you just start with the parallel flies, turning cameras slowly up and up and up. So you take the first line, pointing with the camera 45 degrees, fly manually drone, pointing to the let's say to the wall of the stockpile. Then another line, you fly back, you higher up for 10 meters, turn the camera 10 degrees up, another line, another line, another line, and so on. I will prepare also this document in the future, so we'll have it also here. And this could also help you then to get a nice 3D model, nice point cloud out of it later on DSM, and calculate out volumes and cover the complete stockpile easily. And then one more scenarios, this is already number 6, I believe, are road, rivers, highways, railways, all linear objects. So what's here important to know, have at least 3 lines when you do the mapping, but I think this is already well-known thing. Most of the flying mapping softwares cover this nicely with the linear flight mission. And yes, if you have larger areas, longer areas, like 10 kilometers, fly at least on 80 meters. Otherwise, you will have too much of the processing time and everything like that. And in most cases, on 80 meters, 2 centimeter resolution is good enough, and you can cover this nicely. So remember here, at least 3 lines. And what I would also do it here, because you don't need in most cases 200-meter wide stripe so let's say 100-meter left and right from the road center, you can increase the side overlap to 80%. Okay, and this will even increase you the detailness on the road and close to the road areas, and you are not going to cover too wide areas, the ones you don't need it. Okay. Okay, this was mostly everything from my part. Spend a bit more time as planned, so thank you for your patience, and I'm giving word to Mattia. And if you have some questions to my topic, write it in question box. We will answer them at the end of the webinar. Okay? And Mattia, feel free to continue with your ones.
I just wanted to add a question came up to me. So maybe how about if we plan to do orthophoto traditional or the true orthophoto? Is there any difference in mapping that we should be aware of?
Very, very good question, of course. So for traditional mapping, definitely do a single grid mission with a 90 degrees down. Okay. Otherwise, if you're not going to do that, you're not going to get a nice traditional orthophoto with it. If you like to have a true orthophoto, definitely the best mapping is oblique mission when you have also side images. I believe we have a block about this one.
Yeah, I believe
Let's
there
get.
should be. You can also paste it in the comments or
Okay,
questions
okay,
once you
yeah.
find it.
You should be
And
somewhere on our web page. Let's see later on. We have it here. Okay, traditional versus true orthophoto. So here it's nicely described the beneficial things from one and another and so on. Okay, thank you, Mattia, for question.
okay, and now you know how to fly a drone. But if you're still not convinced to go doing stuff with drones, I have some SLAM devices for you to check out if you prefer this sort of workflow. So let me just share
Okay,
my screen with you.
very
Just
good.
a second, and we are going here. So I'd like to start at this. Yeah, are we here already or not?
I think I'm still
Uh,
on.
so the screen is still black. So
Okay. How about? Mhm.
Are you a presenter, so you're able to share it?
Yes.
So Mattia is presenter, so just go ahead and start the screen sharing. I think it should work.
Okay, let's try this way.
Okay, now
Here we
it's
go.
something happening. Very good.
Yeah, now it's good.
Now
Okay.
it's good. Feel free to start.
So yeah, I wanted to start in this blog post that we wrote about SLAM scanners. We tested 7 SLAM scanners that are available on the market to give you some idea um, what is available. There is, you could say, a flood of producers of equipment, so you get all ranges of quality, origin, price ranges. It's very Wild West style at the moment. So a lot of good devices, a lot of not so good devices, and it's hard to know what is what. So we bundled together these 7 devices from different manufacturers. They don't necessarily compare like one on one because they are in different price and quality ranges. So we tried to get a bundle of devices that would answer to all sorts of users. So we started with StoneX. This one is the one that we knew the best. We did a lot of projects with it. It was providing consistently good results. Some alignment issues and camera could be better, but all in all, a very good device. a CHC nav, very good device also, a bit on the more affordable side, but I won't go into detail for each one of them, especially not Leica. So you may read this on our website. It's all there. We also get some conclusions out of it. Half of this list is more on the budget device, so like FijiD Trion and 3D Maker Pro Eagle. Some of these are, well, hard to take seriously, but some of those perform quite nice and could be also considered for serious use in certain scenarios. So here's the comparison table of strengths, limitations, and some final conclusions. To give you some rule of thumb, maybe if you are a surveyor who cares about low noise, accurate data, consider buying one of these with the drum style sensor, this round sensor, the big one. These perform consistently better than the ones that have sensors like this dome
The
sensor.
button. So
Yeah.
the second one is called Livox, correct? The small button one. This one is the less expensive sensor, and the drum-based, this one is called Hesay. And
Okay.
as far as we know, these sensors were developed for self-driving cars. And because for self-driving cars, they need to produce a lot of them, they are now also affordable for us land surveyors. So this is why I think there are so many these kind of devices out there, because anyone can buy a good sensor and make a SLAM device from it.
So the production is really high. A lot of producers doing this, producing those sensors. So yeah, thank you, Vid, for that input. So, however, all of these devices will give you a point cloud. Some of these, most of those will give you also spherical images. And let's see how it works on the 3D survey side of things. So let me just change my screen now. Okay. So do you see the project? Okay.
Very good.
So once you get back to the office, you should do some post-production in the native app of the manufacturer of the hardware. So that's all done in the SLAM's software. We found the different softwares have a lot of them have some issues because I guess the developers haven't got to polish them yet because the production is so crazy fast. However, once you export those point clouds out of those softwares, we recommend using E57 format. And I will just show you a simple way how you can get those point clouds in. It's a bit different than normal 3D survey workflow. It's a lot simpler. So just go to load, point cloud and load, and let's choose this one. And one more thing I would like to emphasize here is for complete usability and workflow, I have packed most of the features for point clouds from scanners into the scan module. So this time I will show you how it looks if we load point cloud without a scan module. You can still do it. It will still appear, and you will have most of the features there. There's the entire CAD engine. There's a lot of features for visualization, but some of the features are missing. So we'll see that difference. So this is our point cloud. And maybe you noticed we had some little white circles before that are now not visible. These are the spherical images. That's one thing that's only included in the scan module. Then you have this manual and automatic registration. This is also a scan module thing. And if you want to calculate X-ray views, well, it's also a scan module thing. So let's just jump into the same point cloud with 3D survey with scan module. So now you can see nice and clearly there are some white circles here. If we just jump in the random one, yeah, you can see the spherical image, and you can walk through your 3D model in the spherical images. So here's with and I. In the spherical image, you can simultaneously switch between image and point cloud. Maybe let's try to see here. We are looking at the same situation once in the point cloud and once in the image. And okay, let's exit this one. So is my connection a bit okay? Yeah, I'm back. Okay, so this is the point cloud we got out of the StoneX device. And what I'd like to show you now is to get some useful information out of that. My advice would be calculate the X-ray views. So calculating X-ray views has two parameters. One is color transparency. It depends on the density of the point cloud. This one is pretty dense, so I'll put it up to 88 and target resolution 1. We have tutorials that go more in depth on this, so maybe check those out. But even default values would be okay if you wanted to try them. What this will produce for us is the X-ray images of top-down and side views of this point cloud, meaning we will get wall features enhanced, and we will be able to draw in 2D on those plans. So it simplifies our workflow and gives us a few additional features. So it takes about a minute to produce these X-ray views on this point cloud, which is very big. It's also reduced already, but still.
Even on your new laptop.
Even on my new laptop, yeah. So these are the X-ray views. So as I mentioned, they look like X-ray views, don't they? And what is great about those? You can define your own layouts and section on them. So let's say we want to do some layout works, and we will choose this second level. So I'm slicing the area I want to be calculated. So I will just take this part of the building and not all of the height. So I just only get one level of it. Let me show you what I'm talking about. Yes, this is much clearer image of our second floor. This is just beautiful line work, so you can start vectorizing it right away. And if you feel like not drawing lines today, there's a feature for you which will do it for you. So right click on the layout, detect lines. We have some default here, just confirm, and our lines are drawn. Isn't that nice? If you inspect it, okay, you see it's not ideal, but we have added tools for that too. If we go back to CAD, you can see that now in 3D. And if we zoom in here, just a second. So everything looks better now when I'm here. Where was those problematic parts? On this side. Okay. So here we could use a few of those features. The new one that's very useful is intersect tool. Down, second row on the right. Choose two lines and software will find the intersection between them. Again, 1, 2, and they are connected. These two connected. These two connected. It's really simple, and maybe these two as well.
Mhm.
Then we have some other tools like extend and trim, but there doesn't seem to be an example where this would be needed. Perhaps let's try extend here. Yeah, just extend, and it will fill out the
Mhm.
line. Maybe here we can see there are some lines that should not be here. We can simply trim them like this. And
But also with the point cloud with normals, there would be not so many errors here.
yeah, that's one thing you should consider when you're doing X-ray views. It's good if you calculate normals like this. So if you don't have point cloud with normals, you can calculate them in 3D Survey. It's good to export it out of the box, out of
Mhm.
the software that comes with the SLAM scanner. So you have a bit less noise in general.
Mhm. Okay, but you show nicely. So if you would manually need to, decide for all these walls, it would be hard work. So, and combination with automatic and, this stream or extend features are awesome.
Yeah, it meets you halfway, You could also
Mhm.
start
Mhm.
in the X-ray
Mhm.
views. You could just
Mhm.
take the line tool and start drawing yourself,
Mhm.
but
Mhm.
it's a bit easier if,
Mhm.
the software does it for you. Um, One thing that Wid and I emphasized in the previous webinar was when you're using SLAM device with RTK, it's very easy to combine it with drone imagery or drone point cloud. So that's what we did in this project. We did SLAM scan on the inside and drone photogrammetry on the outside.
Mhm.
So this is very efficient way of documenting buildings as a whole. So you have covered everything. You can now do measurements, volume calculations, and all sorts of stuff with this, but mostly for documentation and everything like that. You could upload all of this into cloud and just share it with whoever you want to share it with. Um,
Okay.
There's one more thing I wanted to show. One more use case that that we just got to, let me reset this. One more use case that randomly popped into place. This is our office, part of it, the lower quarters of it. And we recently had a flood in our office, which was unfortunate, but I remembered that you could record intensity of the rebound with SLAM scanners, and I wanted to test if it will show us where the flood got into the walls. So let me give you a hint. This wall was the affected area, and it's true, you can see it visually. There are some dark patches over here. This is water getting out through the wall. But if we turn on the intensity, we can see this much clearer now, wouldn't you say? So the intensity shows us the strength of the rebound, and because the walls are damped with water, some of that rebound got lost, and the value here is much lower than the value here, but this, shouldn't be so because the wall is the same. And one additional view is on the other side. You can see the ceiling here got pretty wet, and we got this nice, no, not so nice patch of damp ceiling. We can also inspect it through image, but yeah, I was standing in the way, so maybe not so good on this one. How about this one? Yeah, and if I toggle between image and point cloud, we can see it's a match. As mentioned, there is a bit of misalignment with these scanners, so we expect that they'll still do some work on that and improve that. But
and they are more problematic from the super close objects. So if you look from the far distance, it's much better. It's better. Yeah, very good.
Better. So yeah, this one was done with StoneX X120 Go. It's a bit less dense than the 200 version, but basically it just takes a bit more time to get a bit more points in there, and your point cloud gets dense as well. Maybe one more thing, this use case would be also great if you're working in environments where there is no light source, so you cannot visually check for water leaks, but the SLAM scanner works perfectly also in the dark. And yeah, that's a solution for you if that's what your line of work is as well. That's it from me. And now, if you have some additional questions, we can also dive into those. But other way, I would give my word to Vid.
Very good. Just a
Okay.
second, maybe.
Thank you, Mattia. Maybe we can go to the questions after I answer this one. I saw there was one additional question regarding the X-ray, but let's leave it for after me. So my topic today will be completely different than the two previous ones. I'll be talking about how we can generate custom surfaces for volume calculations. I'll go ahead and I need to make myself the presenter, enable the screen sharing, show my screen. And now, guys, please let me know, can you already see my screen? Yes.
Good.
All good. All good.
Very good. So we'll be looking at two projects. So this first one will be a little more simple. And in the second one, we will create a little more complex surface. So as land surveyors, we typically, very often, we have to measure some volumes. And often we need to design some custom surfaces in order to make those volumes calculatable. So here I have one example where I have a few different stockpiles. And first, I would like to show you how to define a surface here. So here we only have this measurement, and I want to calculate the volume of this stockpile. How can we create a surface here where we would have a surface as if this stockpile was not present? So when you do something like that, in this example, we will be editing this surface. So in this case, it's good. I have created two same digital terrain models. So this is the first one. This is the second one. The first one, I will first enable it. And this one, we will rename to original. And the second one, this one we will now disable. The second one will be called edited. Right. Now, we will try to remove this stockpile. The simplest way to do it would be to use the select tool, select the area around it, and right-click to confirm. but I will show you a more robust way to select the points inside of the triangles inside of this area. So we'll go to clear here. We will go here into our cat. Here we will create a new layer. This will be stock file area 1. Let's make it red color. Okay. Now what we will do, we will come in here and we will now draw area of interest. So here we will be making sure that we select the area which is mostly flat. So we see that the elevation is approximately 523 meters here. Like that, we go around here and we will end back on the first point. So here it's important that the line is closed. Right. Now we will come here to the mesh. Here only edited mesh is enabled. And we'll use this one now. Select from CAD data. And here with this, we will select all the triangles which have vertices inside of our polyline, which we placed on the stockpile area 1 layer. Press calculate. And this has now selected all of these triangles. And now what we can do, we can press flatten here. And now this ground surface here had been flattened. So this is not completely flat. If we check elevation, so here we see that the elevation on this side is 522.9, and on this side here, it's about 10 centimeters less. So the surface in here is now interpolated. So this is now the interpolation of the surface based on this border that we have drew. So on the intersection of the border and the area of interest. So this is how we can make almost flat area. But very often also in volume calculations, we also have to, sometimes we want to calculate volume from certain elevation upward. I can also show you how to do that. So now we will go here and we will create a second layer. Stockpile area 2, maybe like that. This one will be blue, let's say. And let's draw the second line. So here we will now go here and we will select, we will draw the same kind of boundary real quickly. I won't be 100% accurate, just to make it a bit faster. And here we go here. So here you see that here when I'm cutting, the elevation is rising even to 524. This is because there was a bit of vegetation in this side here, like that. And back down here where elevation is 523. Confirm. Now we will use a similar approach. We'll come here. Here first we will clear so that these points in here will no longer be selected. Now we'll again use select from CAD. And now we will select triangles inside of this area here. Press calculate. Right. So our elevation here is approximately 523.1. So very often when calculating volumes, you have to calculate volumes based on the reference base station. We do that because with TIPIC before, more accurate things were not possible. So we can do that in 3D survey. We can come here, manipulate points, and then we have here this set height to checkbox. And we'll set it here to 523,000 meters. Confirm. And now we have here a flat surface. Now let's calculate these two volumes. So here I have created, have now edited this edited mesh, but we will now compare this to the original mesh. So we'll say like that. We want to calculate how much material is here and here. We'll now go here, calculate volume. So because we want to calculate the fill amount of the volume, so the initial surface here will be the edited one. So the surface that we designed it's like the empty surface. So this will be the surface before, and surface after it's the original. And here we'll go to from CAD. We'll use these two areas to calculate so that the area will be the same. Press calculate. And now we will have created two volumes. So the first one will be a flat volume like that. So this is the interpolated bottom, interpolated base surface. I'll just leave it at that. And this one is 523.00 meter base surface. And we have those two volumes here. So here in this one, the base surface is flat, but it's also very useful because sometimes like that, you can get to eliminate these kind of things where we have some vegetation on the edge of our area, like that. And it will display nicely in our orthophoto view. This is the simple approach. You can use this select and deselect tool to design any kind of surface, but very often it will be hard to do that. So there is a second option that we can use in 3D Survey. And for this second one, I will demonstrate how I would, in this second project, where I have this small construction site area, I will now demonstrate as if here in this area, we excavated a construction pit for a building inside of this. So here in this point cloud, if we have a look, so there is a building here which is being removed. Let's say that a new building will be built here and it will have a cellar, so we need to add some excavation to the site. So in 3D Survey, you can bring in surfaces by going to Mesh, Load, and import a XML-based surface if you have a civil engineer who provided you with one. But if you don't, we actually have the tools in 3D Survey which can allow you to construct surfaces. In this example, we'll only look at how we can create the base surface for this excavation site, but other users also use this kind of tools to create surfaces for new roads or in quarries to calculate how much material they will get if they remove a certain wall or so on. Not to be too long, I will go here into our CAD and I will now proceed to define a surface. So first thing I will do, I will create first the outer boundary for my surface. I will create a layer. This layer will be called number 3, outer boundary for the volume calculation. Let's make this one dark red, like that. Now this part, typically we would draw it very accurately, but here I will be a little bit faster. I will again create a polyline. I will go here and now I will define the area where we will be starting our excavation. So here I will go a little bit around the building, like here, and then I can go here. I'll make it accurate like that. Here, here, here. Okay, so if I were doing this for reals, I would make it a bit more accurate, but now I'm just drawing very fast. So this will be our area for excavation. So here we see that we have approximately 289 meters of elevation. Let's go to Mesh and enable our Mesh. Now I'll go to CAD. So let's say that here we need to dig a surface which will be at elevation of 287 meters. So we have some nice tools here in our CAD, which we can use to help us design this surface now. So first thing that we will do, I will just create a temporary point, and I will now move to this second layer, which I have here, new surface definition. I will just place a temporary point here in the middle so that I can move that point to elevation 200. So I can actually, not sure if you knew that, but if I double click here, I can edit the elevation of this point, and I'll just place it at 287,000 elevation. Not necessary that there are zeros there, but now I have just moved that point to that elevation. What I will create now, I will create a plane on this point. So I will select here, define plane, select the text here, it places a plane on that point. Confirm the plane like that. Now I will draw the inside area of the excavation pit on this elevation. Now in this case, I will use ortho and top-down view so that I can now draw nicely into it. And here we will go now nicely in the area of our building. Let's go here, draw the line. We will start maybe in this side. So when I'm clicking now, actually the point is projected to that point on the elevation 287. Here, here, here. And I will finish here. So maybe, not the nicest boundary, but it will do the trick. Let's see in 3D what we have just drawn. So this is what we have now. One thing very important in this kind of things, these two lines, they can be very close together, but they should not intersect. If they will intersect, when the 3D survey will be creating a surface, it will make a surface with elevation which is the average of these two lines, but you never want this. So basically here you should make sure that these two lines never intersect. Now we will be excavating here. So let's say that we have very powerful trucks and that they can manage at most 10-degree slopes. So most often they will be able to manage 5-degree slopes, but because our area is small, here we will say that that our trucks can manage 5-degree slopes. I will also now design a ramp to get inside here. And to do that, I will come here, draw the line, and here I will enable this checkbox. I want the slope to be displayed like that. And I just wanted, I can't make the text here bigger, so that will be fine. We'll go again to top-down mode. And let's say that our entrance to the site will be here. I will first select now a point here on the slope, and let's disable this info box. So here I want to snap exactly here. We still have the plane enabled. Just reset that plane like that. So again, click here. I have placed a point on the line down there. Now let's go here and we will design such a slope that the angle, that the slope here will be, we set 10 degrees approximately. Like that. And the second part of the ramp, we see here how the size of the car, I'll just make it like that. And again, 10 degrees, like that. And finally, this ramp, this is what we have now. It should also connect to this here. Let's go again, top-down ortho. We'll create also lines like that. And one like so. Right. Now we will use the trim option to delete some of these lines. And okay, I'll trim. We don't need this. We don't need this here. Wait. That, and we don't also need this part in here, and we don't need this part here. Right, now we'll just quickly create a surface from this data. We'll go to mesh, triangulate mesh from CID data. The layers which we will use, support lines, we don't have anything, we just have these two. Press calculate. Let's try to check what kind of surface we have just generated. Okay.
Great stuff.
Not perfect. Here we are missing a line. It got deleted somehow. We'll just create another line. Fix this up real quick. Just create another line here.
There's one more this, yeah.
Probably a bug actually. And now mesh triangulate from CAD data, calculate. And now we have this kind of surface. Now finally, all we need to do is define our area. We see that here we have a couple of these big triangles. We don't want to include them into the volume calculation. We'll just create the final layer, number 4, volume, final boundary, like that. Make this one, I don't know, so that it will be visible, but purple, like that. Now quickly connect the outer layer.
You could also use the copy.
Like that, yeah. And finish. This will be my final boundary. Now go to mesh, calculate volume. So the initial surface will be the current digital terrain model. Final surface will be this triangulated mesh. The area we have on this layer, press calculate. And this is now our excavation. We'll just name it like that. And we have here the 3D model of how much material will be excavated. If we go here into volume, we can check the depth of the excavation. And like that, so using the cat function in 3D Survey, you can basically design any kind of surface. So the one I designed here is a simple one, but I think anything is possible with all the cat tools which are available now in 3D Survey. Just not to take too much time, we'll finish here at that, but you know, cat is becoming more and more powerful in 3D Survey, and I think that will also be the case with the following updates, and so these things are becoming more and more powerful.
Yeah,
right.
More CAD is always welcome, right, users?
Okay, very good. Thank you, Vit, for this. Can you hear me, guys? Am I still live?
Yes,
yeah.
we can hear you.
Very good. So if we quickly wrap up, because we ran a bit out of time, because also of me and so on. So quickly wrap up. I attached the PDF file with the link in the checkbox about how to map, okay? The ones who would like to have it, click on it, download it, because we're not giving this away for free on the web page. It's unofficially now on the webinar because you are here, okay? So download this file and check out again all the scenarios. Mattia nicely explained about the SLAM and everything like that. I will just wrap up the SLAM story with it. Most of the state of the art devices we already support in 3D Survey, and these are StoneX, CHC, Faro Orbis, Fiji Triumph, BLK to go, and more. Okay, so if you have issues, feel free to contact us. We will help you out. And yes, Vit, thank you for this, such a nice playground with the CAD surfaces and everything like that. You see also calculation volume with the help of full 3D mesh, but because Vit knows how to create it, for the safer size, for safer calculation, always try to use regular grid mesh calculation, not to get some wrong results. This is important to know. If you have some balloons in the models, when you're creating full 3D mesh, could be tricky with the calculations. So better use the regular grid mesh that you always have accurate results also. And yes, that's it from my side. Questions
I
and
think we
answers.
can still check the questions and answers, right?
Yes, let's do. Vit,
Yeah,
are you going to do that?
absolutely.
Right. So I'll just go through all the questions, even the ones we've already answered. So the first couple of questions are related to the Marcos presentation. So the first one, are the circular flight, the angle of camera 45 degrees, is it enough? So here my answer was yes, 45 degrees enough, because if we have images recorded at 45-degree top down, the vertical walls will be nicely reconstructed. So we don't need to have bigger camera pitch. Thomas suggested that you can adjust the height of target surface in the pilot application when you are planning mission, and yes, this is true. I think this is a good option for experienced pilots. The third one was with regard to the PDF that Marco mentioned. So eventually this PDF, when it is completely finalized, it will be published on the website under downloads, when you will log in into our website, correct, Marco? But
Yes,
for
something
now,
like that. We still need to negotiate with our marketing department, but yes.
For now, the link to the PDF is in the chat. Then there is a question from Dirk. Dirk, it says, is the X-ray also able to recognize the circles? Here on this subject, we already have some prototypes which are able to detect even curved lines, curved polylines. So we just need to decide in which version we put this update into. So
Basically,
it's not just circles. Yeah, it's not circles, it's any kind of curves. Then Stefan asked the question, how can I determine the volume of a pool with specific water level? But later he also said, we just showed it, thanks. So yeah, we can create a custom surface and we can put that surface on certain elevation and use that one in volume calculation. And the second question from Konstantinos, can I use break lines, hard lines that will have impact on triangle mesh calculation? Yes, I think we showed that. We showed that quickly here in the final example, where I drew the break lines and I constructed the break lines with the help of the define plane option. And Goran is asking, can you include GoSlam T50i? This is the final question we have here for now. Goran, to be honest, I do not yet know this SLAM device. I know that there are now approximate from China. They are coming between 30 and 50 different SLAM companies. If this SLAM enables export of point cloud in E57 format and also export of spheres in E57 format, this will automatically work out of the box. Secondly, if they have an option to export the spheres with the JPEGs and some file which describes where the spheres are positioned and how the spheres are oriented, in the next update we'll be also able to import those. But with this one issue that we see, because this is all so new here, sometimes the data that we get from those devices are wrong. So they might, the rotations might be written in different kind of conventions. So sometimes it does not work. So we will have to try and see if it works first.
So good
maybe
idea,
send us.
probably, yeah. Share results with support, and we will help you out.
Yeah, you can send us an example to the support@3dsurvey.si email, and we will check it out.
Well, I guess that's it. Thanks everybody for
So,
staying with us.
Nicholas also says it's very important points classification. Maybe you can do a webinar on this topic. I think we have a couple of tutorials on this topic, and we also have a PDF available on our website which explains what the different classification parameters mean. Maybe you can check this one first, and if you have additional questions, I can also connect with you online. Just send me an email about the classification.
Okay, thank you guys. So let's wrap up with this one. Thank you all attendees to coming, and we all wish you a great Christmas time. Stay healthy, rest a bit.
And a happy New Year.
Yes, and a happy New Year, and see you after New Year's on January, February with our first webinar. Okay?
Yeah.
Okay, Mattia, Witt, feel free.
Thank you, everybody. Merry Christmas and Happy New Year.
Okay,
Enjoy
thanks for coming. Enjoy.
Bye-bye.
Bye-bye.
Bye-bye.